So we're going to start with our last speaker. So it's my pleasure to introduce Noah Roberts. He's an education application engineer at MathWorks, where he helps universities integrate MATLAB and AI tools into teaching and research. With a background in mechanical and electrical engineering, Noah is dedicated to equip educators with modern practical resources that enhance student learning. Let's welcome our speaker.
Hey everyone, it sounds like the microphone is working, which is lovely. And I recognize that I am the only person standing between you and the end of the day. So I very much intend or aim to keep this under the 5 p.m. time slot that I've been given. So yeah, I guess we can go ahead and get right into it. As introduced, I'm Noah, I'm from MathWorks. I've been with MathWorks for just about 3 years now. And I have a background in mechanical and electrical engineering from WPI, Worcester Polytechnic Institute in central Massachusetts, if you're familiar. And today I'm going to be giving an overview of how MathWorks has developed some teaching tools to work with AI and how they can be used for applications in engineering and science in the classroom. And I've also included some items that you can leverage in light of AI changing how traditional classrooms now operate. And this is, obviously through the lens of MATLAB and MathWorks related products, but there's definitely a lot of principles and takeaways here that can be applied to other programming languages as well in other environments. So here's a list of some agenda topics for today. First, we'll talk about some emerging trends. Then we'll talk about MATLAB Copilot, a generative AI tool that we have within MATLAB. Talk about some project-based learning opportunities, how to enhance curriculum, automated assessment with MATLAB Grader, and then open it up to some Q&A at the end if you have any questions at all. So starting off with some emerging trends. As educators, we want to prepare our students for the jobs that are in demand. But what are some of the emerging fields that we're seeing in industry right now? So some current trends are in fields like robotics and machine learning. But the question isn't so much how we teach our students to solve the problems of today, but the question is rather how do we empower them to learn independently so that they can succeed in the jobs of tomorrow. So various studies have shown that the future landscape will be very different from today, and traditional methods might not be enough for preparing students. It's been suggested that rather than focusing our efforts on memorization, we should instead be teaching them how to learn. And furthermore, the traditional classroom is adequate in reinforcing such learning, or as educators, do we need to also be empowered? So is traditional classroom sufficient for this, or is it broken? And yeah, this title is intentionally provocative. These are just some sample voices from a growing audience of educators who recognize the limits of the traditional classroom. Universities are also recognizing that traditional methods may not be enough. They're investing heavily in classroom technologies that encourage collaborative learning, hands-on experimentation, and creative problem solving. And these are techniques that encourage students to own their own learning and develop the skills necessary to succeed in the future. But how do you make the most of these resources? And how will we engineer the future by educating our students of today? There are 4 steps here that are critical to preparing students to solve the problems of tomorrow, and we'll be discussing each of them and offering ideas and resources to save you time while increasing student engagement in the classroom. So in an ideal world, we'd like to do all 4 of these things in our classrooms. We want to challenge our students with problems that they'll face in the real world. And as a result of rising to these challenges, students will be empowered to take ownership over their own learning. They will have a deeper understanding of how to use all the tools that you've taught them. Throughout this process, we also want to mentor our students, help them learn and succeed at their own starting pace and at their own pace. And finally, our students won't work in isolation. In order to succeed in the workforce, they must successfully work with others and effectively communicate their ideas. And so let's first start off with talking a little bit more about generative AI. And let's assume that we're asking our AI here to find the next word in our sentence. And so we start off with accelerating the pace, and then our AI is going to manage to determine the rest of the sentence and how it should go. In this case, it's accelerating the pace of engineering and science, which if you're new to MathWorks and MATLAB related items, that's actually the MathWorks slogan, so it got it correct. But it doesn't actually understand text the same way that humans do, but it's rather able to recognize patterns in data that it was trained on. So obviously this understands that accelerating the pace of traditionally ends in engineering and science, especially when there's a lot of MathWorks documentation online. And so adapting to a world with generative AI is going to take time. And this is very similar to working with a new colleague, except this colleague has memorized the entire internet, and this colleague is able to complete tasks almost instantly. And this colleague excels at simple tasks and does not complain. And lastly, this colleague can also be overconfident in more complex tasks that it's assigned. And so the three personas today that we're going to focus on and how generative AI applies are the educators, the students, and the researchers. And so how could generative AI boost the productivity of each one of these personas? For educators, Gen AI can create curriculum and give guidance on how to change curriculum. For students, students might see Gen AI as a virtual tutor, providing guidance on how to write code. And researchers can use Gen AI to generate synthetic data and perform literature reviews. And so this brings me to what MathWorks has developed as a solution for a generative AI platform, MATLAB Copilot. And I know that we're probably, if we're in this room, we're familiar with some Copilot products that exist already. MATLAB Copilot is tightly integrated with MATLAB, and the responses from the Copilot are directly based on the latest MathWorks documentation that's written by our wonderful documentation team. This is tuned specifically for engineering and scientific workflows. And there's three main ways that students, researchers, as well as faculty members can leverage MATLAB Copilot. Through Copilot Chat, Copilot in the editor and the command window of the development environment, as well as Copilot Actions. And I'm going to briefly cover what each one of these looks like. Copilot Chat is going to give you direct access to an AI that is based on the MathWorks documentation, as I've already mentioned. And it's a great way to get suggestions for prompting and quickly running code. If you've used other AI, large LLM models, it's very similar to ChatGPT. It's a similar interface here. And as I said, based on MathWorks documentation. And so here's a video of demonstrating how Copilot Chat works directly within the MATLAB environment. In this case, we've asked it for some options on how to smooth outliers. You can simply just prompt the AI chat, which is right on this side panel of your development environment. It'll provide you an answer here. So we've asked it some questions about data smoothing. And it's able to produce us a response that includes not only rich text, but also some coding examples. In this case, it gives us, I think, 6 or 7 different ways that we can do that. Also at the bottom, providing some references as to where it got these from the documentation and some follow-up prompts that you might be asking based on this initial query. And so, as I mentioned, based on this response, we can get Copilot to answer a follow-up prompt regarding the differences between some of these smoothing methods. And so in this case, just going to ask it what's the difference between move median and ample. And then after that, it's actually able to describe to us what the difference between the two of them is, again, sourcing from the documentation. And if I wanted to actually use these code snippets that are produced, I can click the green triangle button, which will actually run that individual section of code directly within my editor on the left side. And so the second way that you can leverage Copilot is in the editor and the command window. And this is helpful for explaining segments of code and getting suggestions while in the middle of programming. And so this video is going to highlight some of the auto-completion capabilities for plotting. And you can add an Ask Copilot live task into your script to modify the code within the code section below. So in this case, we have some state of charge data for a battery. And within line 7 through 10 here, we're asking MATLAB to plot a figure. And it already knows with Copilot that I might want to add some additional elements here. So I've already added, a plot of the time versus voltage, and then the state of charge, and then Copilot has asked me, you want to add some X and Y labels? Would you like to add a legend? Would you like to add a title? Elements that you might not know exist for editing MATLAB plots, but helpful in a way that it will provide those for you. And in this case, also prompting it and asking if we could change the recommended code by putting voltage on the left axis and then state of charge on the right, as opposed to both on the same. And Copilot's able to help out with that too. You can either accept or discard, or even change the prompt for the question that you asked, and then get your plot to change accordingly right within the environment. And so making plots is obviously a strong point of MATLAB Copilot, as well as MATLAB in general. I'm sure that if you ask many professionals what they might use MATLAB for, many times the answer is visualization. And so this video showcases something a little bit even more impressive with MATLAB Copilot. Directly from the interface that we have here, our editor, we created a Copilot action. We've just asked it to create a figure with 4 plots based on some of our data. And so it's able to do that, and it's even able to understand complex plots, such as a group of plots, all plotting different things like state of charge, temperature, current and average current, and voltage and average voltage here. And if I don't like the answer that's been given to me, I can create another Copilot action and prompt it to create a title for me or even a legend. In this case, I've asked it to put a super title, battery measurements. Super title basically just meaning the plot group title for all 4 of them. And so the third method to leverage Copilot is through Copilot actions. And these allow you to explain sections of code and automatically add comments or even create test cases. And so here, I just highlight the lines of code that I'm interested in, and I can ask MATLAB Copilot to directly explain it to me. So in this case, if I don't know what this command means, I can just highlight it, ask Copilot to explain this, and it will tell me that this is actually code for regular expression replacement. And it provides a little bit of a background on what that actually is. And this is helpful because this is actually based off of the MathWorks documentation, so it's less prone to sort of these hallucinations that we might see in some other LLMs. And so in this case, it gives us the what as well as the how. This code adds commas to a string representation of a number to format it with 1,000 separators. And then the how is explained at the very bottom. And if I don't want to have the same problem in the future, I could also use MATLAB Copilot to add comments to my code. And if you're already familiar with the way that MathWorks or MATLAB might create comments, the nice part is that these generated comments follow MATLAB format. So the way that they're spaced out and the way that they describe each one of the lines, as well as a general descriptor for how the function works at the top, is the same exact things that you would see in one of our shift expressions or our shift examples. And so it's understood that adaptation is needed to succeed in a new world with generative AI. And here are some of the ways that a built-in Copilot can help out with these skills. So how do I learn to prompt and iterate on a response? Copilot can help out with documentation on writing good prompts, as well as suggesting follow-up prompts like we saw before. How do I process the generated results? Copilot can try out the code before you actually put it into your editor. And it's also able to give you an explanation for the code that you've written. And how do I know what AI's strengths and weaknesses are? And you can use actions as a starting point for developing code, and you can work your way up from simpler problems. We all know, at this point that feeding an LLM or some other AI model a very complex solution up front isn't usually going to leverage the right results for you. And one way that I like to do it is to start out with plotting, because that's simple. And so jumping back to our 4 pillars that we were talking about before, we can start on how we can challenge our students. So before we can talk about how we can challenge our students, we must understand how students and people in general will learn, and how different learning modalities encourage a mindset of continuous learning. And so how do we break down student learning? I've listed formal, social, and experiential learning, but are they all equally as effective in the classroom? Is it truly 33% across the board? And as it turns out, experiential learning is actually the most effective technique for learning with students. However, traditional methods of teaching lean on formal learning as opposed to the latter two. If formal learning only caters to a small portion of the learning process, how can we get past this and leverage technology to expand on the classroom learning experience? What this study tells us is that we learn by doing, and also learn by making mistakes. And this is learning by being an active participant rather than a passive observer. And so I'm going to also discuss how we can increase some student engagement in the classroom by challenging students with hands-on, real-world experiential learning. This will increase the retention of concepts and keep students engaged with the material. And with generative AI tools able to handle many of the software tasks for students, implementing hands-on learning can assist in a more well-rounded classroom. So one common trend that we're seeing is adding projects that incorporate hardware to courses. It challenges students to learn by doing and thereby improving student engagement. And due to the breadth of hardware support from some of the MathWorks tools that we have, students can learn these concepts and tools that are used in the real world on real data. Being able to use hardware has become such an important skill that industry has developed some low-cost hardware for use within the classroom. And MathWorks supports various hardware, including mobile phones and our MATLAB mobile app. With so many concepts to cover in one course, what if we could integrate various concepts all at once? This enables students to solve more complex, multidisciplinary problems. And therefore challenging them to think outside the box and gain a deeper understanding of how these concepts all work together. Since you probably won't be deploying code to a self-driving car during class, here are some examples of some other projects that integrate with multiple concepts. There's various levels of complexity that we can consider, from a simple line-following robot to a self-balancing robot. And to support educators, we actually partner with Arduino to offer a kit that enables you to teach engineering as a system rather than one concept at a time. And there are 3 projects that are included within the kit, and they use a combination of MATLAB as well as Simulink. We just saw the drawing robot in action, but there's also a self-balancing motorcycle as well as a mobile rover that are included in this kit. And so some of this system-level modeling, multidisciplinary modeling, is what Simulink allows you to do. And with Simulink, students can model entire systems and learn how each piece affects the overall design. Before moving to hardware, students can explore and implement more sophisticated designs without having to write any code at all. Simulation allows students to explore the behavior of a system without worrying about making any mistakes. And after all, there's much to be learned by making mistakes. MATLAB and Simulink work together to create a total design environment for students. And so far, we've talked about how our workflow enables the design and deployment of a single embedded device. But what if we want to monitor, analyze, and act on data from remote devices? For example, how can we monitor environmental data from a remote area? How can we monitor how my products are performing in the field? Then I want to be able to connect those devices into a larger system that enables data collection, communication with other devices, and data analysis. Our Internet of Things, or IoT, web service, ThinkSpeak, lowers the barrier for connecting embedded devices, allowing you to teach students how to work with real-world data. You can set up your own channels, access data from colleagues, or use public channels. And what does a ThinkSpeak project actually look like? And this is an example of a popular one that we traditionally talk about. Traffic might not be much of an issue down here in the Research Triangle area, but in Boston, it is public enemy number 1. And nobody likes sitting in traffic. So in this example, we used a Raspberry Pi, a webcam, and ThinkSpeak to analyze traffic data on a busy highway. And this busy highway is actually Route 9, the road that goes right in front of the MathWorks headquarters in Natick, Massachusetts. And with Simulink, we designed and deployed a traffic monitoring algorithm to the Raspberry Pi, and we analyzed and visualized the traffic patterns using ThinkSpeak and MATLAB. This is actually a public channel that you can access and use in your own classrooms as well. And if you're interested in incorporating ThinkSpeak, our website is a great repository for code examples and things like that. Finally, we also have a full repository of real-world open-ended projects for students to gain practical skills that contribute to solving key industry challenges. And some of these include AI, computer vision, robotics, as well as renewable energy. And so far, we've discussed ideas for challenging students. But each student has a different skill set as well as different needs. They have different starting points and also learn at their own pace. How do we empower our students to take ownership of their own learning, especially in a new environment where they seemingly have every answer at their fingertips? How do we give them the tools necessary to succeed in the classroom? Fostering an environment that encourages a growth mindset sets students up for success as well after they graduate and prepares them for lifelong learning, a skill necessary for the modern jobs of tomorrow. And so one way that we're able to accomplish this at MathWorks is through our self-paced trainings. And our self-paced trainings allow students to spend as much time learning concepts as they need with embedded videos as well as hands-on examples directly in the product. They're guided through the material and learn at their own pace, and you don't have to spend valuable class time teaching MATLAB and can focus instead on your course content. And we offer a variety of courses ranging from the basics of programming to deep dives into advanced topics listed here like machine learning, power systems, image processing, and even app building. And we've also taken the time to create collections of on-ramps in the same areas called learning paths. So if your students are really interested in learning more about machine learning techniques within MATLAB, there's a learning path that essentially combines 4 of the on-ramp courses together to give you all of the basics of learning more about those things. And so faculty around the world have been using MathWorks tools for teaching in different disciplines for a long time. And we have a specific courseware page dedicated to some of the course materials that have been created by your peers outside of just NC State. There's materials like course outlines, downloadable assignments, videos, lectures, and much more. And these are hosted on the creator's end, who you can partner with directly if you'd like. There's material on different topics like intro to programming, and of course, various domains in engineering and sciences. As computational approaches and tools have become more popular in sciences in the last couple decades, so has the use of MATLAB. Another great way to guide students through workflows in a low-code way is actually to use apps. And they're a great way for students to interact with the material and gain intuition before, quote, looking under the hood and being overwhelmed by equations. And this is a really great application for students who might not necessarily be within the computer science domain or have a computer science background, but instead want to leverage some of those techniques that allows you to do. You can see here listed on the some of the MATLAB apps are some classification learning apps, some deep network designing apps, neural net clustering apps, all things that can be leveraged by, say, a mechanical engineer who doesn't really know a ton about how to actually write these from scratch. And once students gain intuition with some of this material, they can generate code right from these apps and then understand how they did the work within the graphical user interface to do it. So students can actually go into, for example, a classification learner and select a specific tree and then develop their model, and then from there it will produce them the full list of MATLAB code that corresponded to the actions that they took within that GUI. And so onto the third phase here, which is mentor. And there's been a lot of interest in individualized learning. And this means that throughout the learning process, students should be mentored and have individualized attention. But how are we able to deliver the feedback to the students that we need in a scalable way? So traditionally, students submit a homework assignment and then wait a few weeks before they can actually receive feedback. And by then, they're pretty likely to be working on the next assignment, and realistically, very few students will go back and review old homework instead of trying to improve on their solutions. Imagine if you could instead give instant feedback and the students could improve on a solution and learn from these mistakes. And this is something that MATLAB Grader is able to leverage. MATLAB Grader helps you create MATLAB assignments that can be automatically graded online for instant feedback. And this is particularly useful for introductory gateway courses where hundreds or even thousands of students are enrolled in performing the same activities. And this is yet another field that generative AI can help out in. With MATLAB Copilot, you can convert assignments that you already have, whether it be as a Word document or a PDF or even a .m file, and turn it into an auto-graded assignment. And this allows you to create new methods to test student knowledge quickly without having to spend hours and hours of actually building and creating this new content from scratch yourself. And if you're familiar with how our MATLAB on-ramps look, MATLAB Grader actually leverages the same exact format. Students will see a description of the assignment on the left side, and then their typical live scripting and working area on the right side. So here, MATLAB Grader actually has some of the test assessments for the students. Their working area is in the middle. And in this case, the user who's using this MATLAB Grader assignment even has the debugger open on the right side. And so the age-old question very likely needs to be asked, because we're talking about generative AI, we're talking about assessments for students, and we're talking about an intro programming class. Obviously, the question of academic integrity will come up. So what motivates learners to cheat in programming assignments? And some of these methods are outside of your control, outside of instructors' controls. And these include lack of prerequisite knowledge. If a student isn't confident on a topic, they're probably more likely to seek an answer from a generative AI that can give them any answer that they might need. They might be crunched for time with several finals, and they think that this is the only solution to get them the answer. They may have competing priorities with club meetings and other things that keep you busy in college, as well as peer pressure from others that might be leveraging these generative AI tools to solve their homework answers. But there are some methods that are within the instructor's control, such as learning environment issues, or limited time, such as exam windows, deadlines, or due dates, as well as limiting access to teaching staff and resources. And so some countermeasures to motivate students that are outside the instructor's control are to show a connection between the coursework and career skills using MATLAB, assign off-the-shelf resources, videos, courseware, or trainings to reinforce prerequisite MATLAB skills directly in your learning management system. These include some of the MATLAB on-ramps, some of the learning paths that I just talked about. You can also talk about academic integrity in your course syllabus and let learners assume that everything is recorded. And finally, you can use techniques like pair/peer programming, group projects, and team evaluations to identify, recognize, and grade individual contributions. And so far, we've discussed how to challenge, empower, and mentor students in the classroom, but how can we encourage students to grow their network and interact with the community as a whole? Student competitions are a great way to get students involved. We support dozens of student competitions worldwide each year in all kinds of fields, including automotive, aerospace, robotics, and even biotech. At the Formulas Student Germany competition, over 100 teams use our products to simulate strategies, analyze performance, and implement different control designs. RoboBoat challenges students to develop a boat that can autonomously navigate through a series of channel markers. And lastly, RoboCup is a global competition where students field teams of autonomous robots in simulated soccer matches. But how do we ensure the access of these computational tools to the students and faculty are done in an effective way? And the idea is not to confine students to computer labs alone to ensure their access to these tools. And universities have a MATLAB portal in form of a private landing page hosted by MathWorks that gives a self-service solution for login to software download and getting started on some different resources. And so NC State actually has access to a MATLAB campus-wide license, which is a key enabler for this. There's over 4 million students in over 1,300 universities today that have access to this, and they can access MATLAB anytime from anywhere on their personal machines. Another way that students can connect outside of just ThinkSpeak as a cloud platform is actually through MATLAB Online. And MATLAB Online is a convenient way to use MATLAB without having to download or install any software to your device. It's completely cloud hosted. The interface is identical to what you might see in your locally installed MATLAB, except with the convenience of running the latest version of MATLAB within a web browser. And in terms of storage, every student gets 5 gigabytes of space on MATLAB Drive, and your data encode is available to you on all of your devices, including your tablet or mobile phone through MATLAB Mobile. And MATLAB Mobile allows you to use your smartphone or tablet device for running MATLAB code. You can interact with MATLAB Desktop and Drive through it as well. And it allows access to raw data from your smartphone sensors that can be leveraged for various applications. Functionality from MATLAB Copilot is also coming to MATLAB Mobile in one of our next releases. Rather than consistently reminding students to put away their phones, imagine if you could actually leverage them in the classroom as a tool. For example, you can use some of the sensor data from a mobile phone to design projects such as step counters for students. One thing that I thought was important to share as well today, because it was mentioned several times, is the ability to connect MATLAB with other languages. So there's a variety of languages that MATLAB also interacts with through some APIs, and most importantly Python. I heard that mentioned several times today. If you already have workflows developed within Python and you want to, say, perform some visualization within MATLAB, instead of having to choose one or the other or convert all your MATLAB code to Python or all the Python code to MATLAB, you can directly interface Python from MATLAB or MATLAB from Python. And additionally here, you could probably leverage Copilot, specifically MATLAB Copilot, to help convert back and forth if you truly needed to. I also heard this mentioned several times today, but you can also leverage MATLAB from a Jupyter Notebook environment. So if you leverage Jupyter Notebooks as part of your course as a teaching tool, MATLAB is a language that you're able to interact with as part of those Jupyter Notebooks. And lastly, I just wanted to go ahead and reintroduce myself as the dedicated MATLAB engineer for NC State. So if you're an educator or a researcher and you're looking to hear a little bit more information about some of the tools that MathWorks and MATLAB offers for your specific workflow, that is my entire job, to assist you and help you out with that. So I'd be happy to speak with you after the fact here or over email via my email that is currently on the screen here. And yeah, I kind of sped through the presentation, hopefully, because at the end of the day, I want to thank the College of Engineering for hosting me. Thanks to Jack for setting everything up with the presentation. Thanks for Edgar for inviting me, as well as thanks to my colleague Elvira for traveling down with me to NC State. So yeah, thank you everyone for your time. I know it's the end of the day, and I'm open to any questions that you might have.
Let's see if we have a couple questions. Any questions from the audience? Go ahead. End of the day, I know.
So MATLAB seems to be moving to become more and more connected and more sophisticated programs. For instance, ANSYS, we use ANSYS. So is MATLAB, first of all, the first question I have is, does MATLAB connect to ANSYS, or is this is a high level, or does ANSYS reach out to MATLAB for the collaboration? And then the second question is how many more collaborations like this are you planning? Where's MATLAB going for the future with all this happening?
So they don't tell me much about I'm going to answer this in reverse order. They don't tell me much about the way that we're planning on collaborating with certain companies in the future, or certain environments in the future. I know that the Jupyter Notebooks collaboration was something that was talked about for a while. It finally came through. And I don't know specifically off the top of my head the ins and outs of how the API works back and forth with a software like ANSYS, but I'd be happy to speak with you after and figure out a little bit more about how that actually works back and forth. So my role is not necessarily to know every answer, but to direct you to somebody who would know all of the answers as necessary. So yeah, I'd be happy to dig into that and get back to you. Yeah, thank you for the question. Yeah.
Thank you. I think there's another question.
Yes. Yes, I have a question.
I think he needs to turn on the mic.
I can hear you.
Yeah. I'm asking about the hardware which you can use with the MATLAB.
Mm-hmm.
Like Arduino, it's compatible with the MATLab. Is
Yep.
there any specific hardware which MATLAB systems use?
Yeah, so you're asking about specific boards that MATLAB is compatible with?
Yes.
Yeah, so we actually have, and actually we'll do this live because we're here. We actually have a full documentation page, and I'm not on the internet. we have a full documentation page that outlines what different tools we're compatible with on the hardware side. It's nearly every single Arduino board. I know that it supports some software-defined radio stuff, many HDL, FPGA related items, Raspberry Pi, ESP32, BeagleBone. So there's a whole documentation page if you were to look up, if you were on the internet, unlike me, and just look up MathWorks hardware compatibility. There's a whole list of different things that are compatible there. I'm decently well versed in some of the low-cost hardware stuff related to MathWorks tools. So if you want to chat about that as well after the fact, I'm happy to.
Thank you.
Of course.
I got a question here.
One more question over here.
So how do you feel about, you said that learning by making mistakes. One of my concerns of code generation, by actually asking to generate code, is that they're going to be making less mistakes because they're going to be using code that's proven and that works. Do you think that by going through this program, are we going to weaken our muscle of learning the hard way and then produce engineers that are going to be almost you want to support role and then have AI be the primary role player? How do you feel about that?
Yeah, I think that that's definitely an incredibly high-level question when it comes to how learning is changing in general, and I think that that's one of the themes of this entire program in general is how are we going to pivot learning now that these opportunities are at their fingertips. And we receive the questions all the time regarding Copilot is that if you put the genius right within the environment for them, are they going to be more likely to use it? And a lot of the statistics behind it says that students will find an answer like that regardless. When it comes to the academic integrity related items, students are going to seek out an answer because of factors unrelated to the product itself, like peer pressure, like maybe deadlines and things like that. And so they will seek out that answer. And I think that does, and I'm by no means the authority on this if you're asking my opinion, I think that, yeah, it's a concern that perhaps students are going to learn those basic muscles for what does this specific expression mean? Where can I find this in documentation? How do I leverage this function? How do I use a switch case? How do I use a for loop? Things like that. And I think that that's a much larger question as to how that's going to pan out in, I think, the coming years with certain curriculums as well as in industry as well. Because I exited college right before all of the AI and LLMs hit and things like that. So I'm very much on the outside of understanding how a student experience might be going with this. But I think that the MathWorks tools that we currently provide regarding Copilot and such is just to sort of follow along with what's currently going on with industry, with LLMs that are being created here. And I think the best answer that I can give is I don't know. And I'm not overly confident as well to know what the solution is going to be down the road. Are we going to provide students with enough of the support that they're going to be able to know this information themselves? It's definitely still, and I think will continue to be, a very open question as to whether or not these tools are supporting student learning at the end of the day in all the ways that they can. And I think that the nice part about conferences like this is that we come together and we chat about how we can actually make sure that these students still have those baseline skills in programming and debugging, despite having access to LLMs that can give them seemingly any answer at all. So Yeah, I wish I could give you a yes or no as to whether or not this is the future or the right way to
Yeah,
go.
that's a great answer because we're dealing with the same issue with companies that are actually producing software these days. We're working with them, trying to just answer that question. Because next year is going to be crazy how much built-in AI is going to be on applications that are coded these days for other industries. So it's happening, and that's one of my concerns. What's going to happen with, with all the guys that spend late nights doing this, learning this, and now you can do it within 30 minutes. All the hard work pays off, and we are kind of seeing that because we did this 20 years ago, at least in my case. What's going to happen with the new generation? So that's a comment that I have to. So thank you for being honest with your answer.
Of course, yeah. I mean, yeah.
Absolutely right.
I think the short answer is that, yeah, it remains to be seen. And our job as, researchers, educators, as well as, industry partners that work directly within, the education space very heavily. It's our job to, have open conversations like we had today about where the course of, this applied AI and LLMs are going to play a role within the education space. So, yeah, definitely a worthwhile question. So, thank you.
I think we have a follow-up and another question.
I just have a commentary.
Oh yeah, this is Elvira, my colleague. She also works at MathWorks. So.
Yeah, so I used to be in your seat. I used to be faculty before I joined MathWorks. And I think about this all the time because I think one of the things that I used to see before all this stuff existed, I was faculty before this existed, is that the students really hated to fail. And I taught a lot of grad students, and you're like, no, you work in a lab. Like, it's gonna fail 9 times out of 10. Like, that's just what research is, right? They're gonna fail constantly. And it was really hard for them to kind of accept that, right? And so then I think about it in like this context where like, they don't even get problems wrong anymore. So what happens when you get to grad school and now you have to like invent science, right? Like you're pushing the boundary of stuff and these things may not be able to answer these questions anymore. So I don't have an answer, but these are just things that I think about a lot because that's what we do as engineers and scientists, right? We fail and fail and fail until it works. And so if you don't have that mindset, like, what happens, right?
Thank you. We have a question on the back.
Hi. You mentioned earlier about the competitions and the different projects. I don't know if there's been enough time to get data on this, but I was just wondering if you've seen an increase in creativity in these competitions and projects since you've implemented the help?
Yeah, creativity, how? Do you mind expanding on that?
Like, for example, project scope or just like, so I do use, I don't use MATLAB, but I do use LLM help for coding. And what I find is, as you were saying, you still have to come up with your own research questions. You still have to come up with your own experiments. And having these, having the help has enabled me to run more experiments faster because I'm not looking up, documentation from libraries. I also use these tools to learn more about algorithms and like that specific algorithm, and like for instance, if there's an edge case I'm curious about, I'm not spending time reading a textbook on the algorithm. I type in, well, what would happen in this edge case? Like, give me some examples. And so I'm just curious in these competitions if you're seeing better, well, I don't know if it's better, but I guess more advanced projects that are coming through since they have faster access to getting some of the more complicated questions answered. And they're not dealing so much with code, they're dealing more with the problem definitions, because they can now.
Mm-hmm. Yeah, so I don't work directly with the student competitions teams. We have a dedicated team at MathWorks that works directly with this, but I do know that these are issues that are, well, I say issues, but there are things that are occurring within these competitions themselves. I think that one of the best parallels that I can make is that I also work with another one of my colleagues back in the Boston office similar to like an applied AI, like an AI project challenge with Northeastern and MIT. And with that, students are tasked with using AI to solve some sort of challenge project, similar to the challenge projects page that I had showed a little bit of. And my group specifically is delving into how they can take some IMU, inertial measuring unit data, and turn it into a working model to determine if somebody falls down, if they're healthy, are they walking enough. And I know specifically that project scope has changed a lot because of the way that generative AI now exists. And now the students are tasked with logging when they're using generative AI, as well as coming up with more complex solutions than before. I know when I was talking to the person who manages that entire program, they mentioned like, hey, we want to make sure that these project scopes are a little bit more complex because some of that early on stuff, some of that busier work for the students is going to be handled by some of those large language models, those AI tools. So the students are definitely leveraging those in these sorts of competition settings. And I would say that, at least in the settings that I've seen it in, it definitely challenges the students and pushes the scope a little bit further because some of that groundwork is already laid before them. Yeah, as far as student competitions like VEX and Formula SAE, I don't know specifically the ins and outs of that, but in some of the different student events that I've supported, I definitely see yes. Yeah.
Thank you. Are there any other questions? If not, let's thank our speaker one more time.
Thank you all.